So let us look at a problem here, and it is a piecewise function. And a piecewise function is defined on certain intervals. So to the right you have the function, and to the left is the function, and to the right are the conditions. So let's recreate this, and let's start with the first one where x is less than 1. So we know that x is the identity function. So we want to just draw first the identity function, and I'm going to show you how to do this. So I'm going to draw a line here, and it's a good idea to do this with a pencil. Now notice that our conditions are just 1 through 3. So I'm going to space this out and make every 2 boxes. So this is 1, 2 boxes, 2, and the 2 more boxes, we're going to call that 3, and of course this would be 4. All right. Now the actual definition says where x is less than 1. So these are our x's. So I'm going to go here. 1, 2, 3, 4. Now, if I take these functions here, and it says when less than 1. So even though it's not defined, I'm going to say if x is 1, what is y? So what's f of 1? It would be 1. So for here, this particular part, it's not equal to, so I'm going to put an open dot here. All right? And I'm going to go in and take this out. Clean this up a little bit. So that's the part of the function that we want. We want the part that's less than 1. So we did the first one. Now the next one says 3, but it's when x is greater than 1, equal to, and less than, and also equal to 3. So that's, we're going to jump up to our 3, and I'm going to put a closed dot here. And it's going to be equal to 3. So put a closed dot here and put a line there. Now it wants the identity function again, but this time it says 3 and continue on. So here. Now notice that in the definition it is not equal to on this piece, but it is equal to on this piece. So whenever we're in this kind of a situation here, we're going to let the equal to part override the non-equal to. So even though it's not defined for this part of the function, it is defined on that part of the piecewise function. Now we're going to answer some questions about limits. So let's pose a question. So the lim of the function as x approaches, let's take 1, and I'm going to make 1 from the left. What does it equal? So let's go look at from the left. So this piece up here at the very top, this is from the right. This part is from the left. So as we approach 1, we're approaching this value here, we're essentially asking ourselves, when x is 1, what is y? So let's look at the graph. When x is 1, well, what is y? Well, it's not defined, but that's okay because we know the definition of a limit is the value that cannot be obtained. So the fact that it's not defined does not mean that there is a limit does not exist. So as we approach 1 from the left, we are approaching what would be the y value of 1, so that is what our answer is going to be. We will have 1. Now, let's go on to another question. Let's pose a question lim as x approaches 1 of the function here. And this time I want to say from the right. And what does it equal? So now we're back to the top part. From the right. So we start right, go left, and we get to 1 and we stop. What is the y value when x is 1, right here? When x is 1, what is y? From the right, it is 3. So I'm going to go ahead and write 3, and there it is. So remember that these two symbols, the minus sign and the plus sign on the lim, are left and right. Now, my last question I want to ask is going to be the lim as x approaches 3. I want to approach 3. And I'm not going to put anything above the 3. And when that occurs, that means from the left and the right. So from the left here and from the right there. What is the y value? So we ask ourselves a question again. When x is 3, what is y? So we look at our graph. Looks like here is 3, there is 3. So we know that our answer is going to be 3. So we're going to get 3 as our answer. That's how you understand limits when defined by a piece value function. Now, you can be given a function without this and still be able to interpret the answers. And that's what we're going to look at next. We're going to look at a problem with just a graph, and from there, you're going to have to identify the limiting values. Okay?